August 31, 1931. The Arctic. Above the icy surface, like a steel silhouette against the silent whiteness, an unusual submarine moves, the Nautilus. This vessel was unique in that it was the first submarine to reach these latitudes under its own power. Its appearance was radically different from standard military submarines. Massive protrusions, modernized plating, and non-standard equipment were evidence of a large-scale overhaul of the hull specifically for the task of passing under the ice of the Arctic Ocean. On board were Captain Sloan Denenhauer, an experienced sailor with a cool head and measured actions, and the inspiration and organizer of the mission, Australian polar explorer Hubert Wilkins, who was obsessed with the idea of exploring the Arctic seabed from within. Over the past few weeks, they and the crew had gone through many difficulties, and now the submarine was at the very edge of the ice, where the density of the ice field was rapidly increasing, posing a real threat of crushing the hull. Ahead lay what seemed to be an insurmountable mass of frozen ocean. But it was precisely beneath this mass that the boat had to dive and pass through for the first time in human history to prove the possibility of Arctic sub-ice navigation. Aware of the risks, the captain gave the order for the crew to check all compartments, the condition of the equipment, and the external elements of the vessel. Antennas, handrails, and external structures that could be crushed or torn off at the first collision with ice masses were urgently removed from the upper deck. The situation was tense. Suddenly, a report came in. During an inspection of the stern, serious damage was discovered. The horizontal rudders were completely missing. Most likely, they had been torn off or destroyed by a collision with drifting ice floes during maneuvering. This meant one thing: the boat was physically unable to dive. Without rudders, it had lost vertical control. The captain went downstairs to report this personally to Wilkins. The researcher's response was cold and harsh. "If we don't complete the task and make the underwater dive, we're doomed. There will be no funding. It will all be for nothing." He stood his ground. The mission must be completed, despite the technical problems. Wilkins insisted on implementing the plan at any cost. After some thought, the captain proposed a desperate but only possible option: to take ballast into the bow tanks and try to force the boat under the ice using the thrust of the propellers. This maneuver was tantamount to suicide. The Nautilus would effectively lose its maneuverability, and the slightest mistake could leave it stuck under the ice, with no help in sight. However, Wilkins, driven not only by scientific interest but also by the need to justify the mission's funding, was willing to take the risk. All crew members descended into their compartments. The command was given: close the hatches. After taking on water into the bow ballast tanks, the submarine tilted forward, taking on a list to the bow. The captain gave the order, "Forward!" and the Nautilus, shuddering from the impact with the lower edge of the ice floe, began to descend into the depths with a roar. It was a moment of extreme tension. If it failed, tragedy was inevitable, but if it succeeded, humanity would penetrate the Arctic ice for the first time. The history of this unique submarine with the proud name Nautilus began long before the Arctic expeditionary feat on March 6, 1916. In Bridgeport, Connecticut, a diesel-electric torpedo submarine designed for the U.S. Navy was laid down at the shipyard. It was typical of its time: 52 meters long, 5 meters wide, with a submerged displacement of 639 tons. The power plant included two 150-horsepower diesel engines and a pair of 370-horsepower electric motors, which allowed it to reach speeds of up to 14 knots on the surface and up to 10 knots underwater. The armament was modest but quite adequate for training purposes: 4 450mm bow torpedo tubes, with a stockpile of 8 torpedoes, and one 76mm deck gun that could be retracted into the hull, leaving only the barrel protruding from the deck. The crew consisted of 29 people. Boats of this design were generally intended mainly for training and auxiliary purposes, and therefore rarely participated in combat operations. Some of them survived until 1946, having served peacefully for decades. This particular submarine, designated O-12 at the time, was commissioned into the 1st Division of the U.S. Navy submarines, based in Coco Solo, in the strategically important Panama Canal area. For a long time, it performed unremarkable, routine peacetime service, carrying out training missions, exercises, and patrols. It is worth noting that the service history of the submarine, which later became famous as the Nautilus, was rather short and unremarkable. In June 1924, After only 5.5 years of service, the boat was taken out of active service with the U.S. Navy and sent to the reserve, moored in Philadelphia. It was considered obsolete, and there were no plans for its further use. Moreover, the option of complete decommissioning and scrapping was considered. On July 29, 1930, the submarine was officially removed from the U.S. Naval Register, thereby ceasing to be part of the combat fleet. It would seem that its fate was sealed, scrapping, like most ships at the end of their service life. However, it was at this moment that a man appeared in the submarine's destiny who forever changed its purpose. In America, he was known as Captain Wilkins, although his real name was Sir George Hubert Wilkins, an outstanding Australian, polar explorer, ornithologist, and photographer. His biography was as rich as it was heroic. During World War I, he served as an officer in the Australian Corps, performing the duties of a war correspondent. He became famous after the Battle of the Hindenburg Line in 1918, when, as the only officer left nearby, he took command of American soldiers who had lost all their commanders. For his courage and leadership, he was awarded the Military Cross. After the war, Wilkins turned his attention to scientific interests, particularly ornithology and polar research. In the 1920s, he took part in several Arctic expeditions, where he not only studied the fauna but also developed methods of survival in extreme conditions. By 1930, Wilkins, together with his colleague, the famous polar explorer and aviator Lincoln Ellsworth, had conceived a truly daring and adventurous project to conduct an Arctic expedition under the ice aboard a submarine. It was an idea bordering on madness at the time. The expedition's goal was not only scientific interest. Wilkins and Ellsworth planned to collect comprehensive meteorological data, conduct oceanographic measurements, and establish the practical application of submarines in sub-ice navigation. It was a project at the intersection of science, engineering, and military planning, to prove that submarines were capable of navigating under Arctic ice and thus potentially had strategic significance. The expedition received funding from several sources. The Woods Hole Oceanographic Institution and influential newspaper magnate William Hearst invested their own funds, on the condition that the expedition would provide exclusive photo reports and interviews upon their return from the voyage. In addition, Wilkins and Ellsworth themselves invested their own funds in the project, which speaks to their deep confidence in its success. Instead of building a submarine from scratch, which would have required fabulous costs, the researchers decided to use an existing submarine. After studying all possible options for decommissioned and reserve submarines available to the U.S. Navy, the researchers settled on the O-12 submarine, one of a class of boats that had long been taken out of active service. Sir Hubert Wilkins could not purchase it because he was not a citizen of the United States, and the sale of military property to foreigners was strictly prohibited. However, he managed to obtain permission to lease the submarine with one condition. At the end of the expedition, the boat had to be returned to the fleet and scrapped, i.e., dismantled for scrap metal. Thus, the fate of O-12, according to the U.S. Navy's plan, was still sealed, but before that, it was to play one of the most unusual roles in the history of the submarine fleet. Wilkins and Ellsworth's plan was for the submarine to enter the Arctic ice, then rest its upper part against the lower surface of the ice and slide under it like an upside-down sled, moving by means of propellers. To allow people to exit onto the ice, where they were to conduct research, special retractable channels were installed in the hull of the boat, through which aquanauts could drill through the ice and crawl out. To perform such operations, the submarine needed a radical overhaul, both externally and in terms of functionality. It was decided to carry out the reconstruction at the same Philadelphia Naval Shipyard where the O-12 had once been built. Interestingly, Simon Lake, a famous American submarine designer and one of the pioneers of submarine construction, personally got involved in this project. On his initiative, the upper hull was removed from the bow to the stern, and a special massive superstructure was installed, resembling a second hull. Its height reached the level of the hatch, and the interior of the superstructure had a system of frame reinforcements, additional supports that ensured the strength of the entire structure when in contact with ice. The design features were not limited to the hull. The bow and stern of the superstructure were designed with slopes, and metal runners were attached to their surfaces, which ensured sliding on the lower surface of the ice. Thus, the submarine could act as an object crawling on the ice without getting stuck, but rather using the resistance of the ice to stabilize its movement. At the same time, in the surface position, Hatches remained on the upper part through which antennas and masts could be raised. However, before diving, they had to be folded inside the hull. Otherwise, at the first contact with the ice, all the extendable elements would be torn off or broken. The bow torpedo compartment of the submarine was radically redesigned. From a combat space, it was turned into an airlock chamber designed for the exit and return of research divers. The 4 standard torpedo tubes, previously located in the bow, were dismantled, and all openings and joints were plugged and sealed to prevent leaks and simplify internal watertightness. In the center of the converted compartment, a main escape hatch was installed, leading downwards. Through it, submariners could leave the vessel even when it was completely submerged, as long as the boat was not lying on the seabed. All instruments, units, and devices previously used for navigation, combat, and submarine control in military conditions were also dismantled. They were replaced by food supplies, equipment, air cylinders, and scientific instruments. The main task was to maximize the usable interior space, transforming the boat from a combat unit into a research platform. A retractable telescopic shaft with a sealed hatch was installed where the deck gun had previously been located. A drilling rig capable of penetrating the thickness of Arctic ice was placed at the top of the shaft. Several retractable pipes were also installed on board to supply fresh air to the boat and remove exhaust gases from the diesel engines. Pneumatic icebreakers, which were powerful metal cylinders operating under high pressure, were attached to these pipes. Their task was to break through vertical channels in ice up to 4 meters thick so that the crew could get to the surface and the boat itself could access the atmosphere. In addition to the vertical drills, a horizontal hydraulic breaker was installed in the bow of the submarine. It consisted of a cylinder with a system of hydraulic tubes and an impact piston, which, if necessary, broke through the ice in front of the moving boat. From the outside, only a neat cut in the pipe was visible on the deck, concealing a complex system under the hull armor. An additional emergency airlock chamber was installed in the steering compartment, closer to the bow. The exit from it led through the main deck and superstructure, and in the event of an accident or failure of the main chamber, it could become a lifeline for the crew. Another interesting device appeared behind the wheelhouse, a roller-type ice thickness gauge. This device consisted of a frame with a rotating roller, which was raised from the deck by a pump and, upon contact with the ice, allowed the crew to accurately measure its thickness at the point of exit. As a result of such a large-scale reconstruction, the submarine changed dramatically and acquired unique functionality that was unparalleled at the time. In honor of the famous fictional submarine from Jules Verne's novel 20,000 Leagues Under the Sea, the converted boat was named Nautilus. The Nautilus submarine was ceremoniously launched on March 24, 1931. The ceremony was attended by the grandson of Jules Verne, the famous author of the novel 20,000 Leagues Under the Sea, in whose honor the real submarine was named. According to old maritime tradition, a bottle of champagne had to be broken on the hull of the ship for good luck, but at that time, prohibition was in effect in the United States, prohibiting the sale and consumption of alcohol. Therefore, instead of champagne, a bucket of ice was broken on the hull, which symbolically reflected the Arctic focus of the mission. After the descent, the boat faced an extremely tight testing schedule. Only 2 months were allocated for checking mechanisms, adjusting systems, loading supplies and scientific equipment, and arranging the interior compartments. Despite the complexity and novelty of the expedition, the crew consisted of only 20 people, including Hubert Wilkins himself, who acted as the expedition leader. The vessel was directly commanded by an experienced submariner, Captain Sloan Dunhauer, who had previously commanded the C-4 boat. The entire crew was made up of professional sailors, mainly former military submariners, who were selected through an extremely rigorous process. There was no room for amateurs in the Arctic. According to the plan, the mission's route was as follows. From New York, the submarine was to proceed to the British port of Plymouth, then to the Norwegian city of Tromsø, and from there northward through the ice to the North Pole, where, according to the plan, a meeting with the German airship Graf Zeppelin was to take place. This symbolic act was to be the culmination of the expedition and attract worldwide attention. To partially offset the enormous costs of the mission and attract additional funding, Wilkins developed a postal campaign. He offered anyone who wished to send letters via the Nautilus, from continent to continent by underwater route. Special collectible envelopes with an image of the submarine were produced for this purpose. The idea resonated with enthusiasts, and several bales of letters ended up on board the Nautilus. Despite the symbolic payment for shipping, it was not possible to raise a significant amount of money. Nevertheless, on June 4, 1931, the crew finished loaded provisions and scientific equipment, and set out into the open ocean. But at the beginning of the voyage, the expedition encountered serious difficulties. In the Atlantic, the submarine ran into a severe storm, which resulted in both diesel engines failing. Having lost propulsion, the boat began to drift, which in Arctic conditions could have been disastrous. The battleship Wyoming came to the aid of the Nautilus, towing the submarine to the nearest port for repairs. This force majeure delayed the expedition by almost 2 months. On August 1st, the Nautilus submarine arrived at the Norwegian port of Bergen, where the crew refueled, loaded additional supplies, and partially replaced the crew. After a brief stop, on August 5th, the submarine set course again for the north, towards the Arctic. However, the vessel soon encountered another violent storm, which resulted in the failure of both diesel engines, for the second time during the expedition. In this situation, the Nautilus was once again left with only its electric motors, which had much less power and autonomy. Nevertheless, the submariners managed to reach Spitsbergen Island, where they were able to carry out emergency repairs. After successfully restoring the ship's systems, the submarine continued its journey north on August 18th. Soon, the vessel reached the 82nd parallel north latitude, an incredibly harsh area where the sea was literally frozen under a thick crust of ice. Progress slowed dramatically. Ice fields constantly blocked the way, forcing the crew to stop, look for detours, or attempt to ram through the ice, risking damage to the hull. The air temperature dropped sharply, and the frost penetrated inside the submarine, creating unbearably difficult conditions for the crew. After all, the boat was not originally designed for operation in such Arctic conditions. In some places, the hull began to leak, and the ventilation system struggled to cope with moisture and condensation. The expedition's plans were literally falling apart before their eyes. It became clear that if the team wanted to return home alive, time was running out, and they needed to manage to accomplish at least part of what they had planned. Mission leader Wilkins understood the criticality of the situation and therefore insisted on immediately conducting a key experiment: submerging the submarine under the Arctic ice, even if in a reduced form. August 31st was the decisive moment. The crew began preparations for the unique dive. However, during the final inspection of the vessel, a serious obstacle arose. It was discovered that the horizontal rudder planes at the stern had been torn off, probably destroyed by ice. Without them, the Nautilus lost its ability to maneuver underwater, which made the passage under the ice extremely risky. But there was no turning back. After consulting with Captain Sloan Dunhauer, a risky decision was made: to use the bow trim, ballast, and special skids installed on the hull to roll under the ice like an upside-down sled, using only the thrust of the propellers. The entire crew descended inside, the hatches were closed, the antennas and protruding elements were removed, and the operation began. Water flowed into the bow ballast tank, submerging the submarine's bow. The electric motors started up, and the Nautilus headed for the ice edge. The first attempts were unsuccessful. The submarine struck the ice several times with its bow, unable to break through or go under it. The captain ordered ballast to be taken into the stern tank to level the trim after the bow went under the ice. The Nautilus submarine rumbled and rattled as if the hull was creaking from incredible tension, and the surrounding ice could crush it like a tin can at any moment. Every member of the crew held their breath at that moment, listening to the frightening clanging of metal and feeling the entire structure of the vessel shake under the pressure of the ice. However, when the submarine completely entered the lower edge of the ice, relative silence ensued, the rumbling subsided, and it seemed as if the ship had hidden from the fury of the Arctic in its own icy depths. After leveling the trim, the captain gave the order to move forward, and for the first time in history, the Nautilus slowly began to slide under the thick layer of perennial ice, like an overturned sled. It was a moment of triumph, especially for Wilkins, who knew even while still on shore that if the sub-ice dive was not completed, the expedition's main investor, media mogul William Hearst, would not pay the promised funding. The mission was hanging by a thread. Nevertheless, the team did not risk staying under the ice for long. The danger of being trapped, system failure, and rudder malfunction forced the captain to give the order to reverse. The boat slowly emerged from under the ice floe and surfaced. An unpleasant surprise awaited everyone on the surface. The cutouts of the retractable channels and drills were deformed. It became clear that the drill test would not have been possible in any case. The ice had severely damaged the structures. The retractable channels were jammed, and any attempt to use the bumpers could have led to fatal damage to the entire superstructure. In addition, it turned out that the communication antennas, despite being folded and secured, had still suffered serious damage. The Nautilus was left completely without communication. But even in these difficult conditions, experienced engineers from the crew were able to repair the antennas in a few days, assembling a new radio communication system literally from scrap parts. This made it possible to establish contact with the outside world and transmit information about the progress of the expedition. After that, the captain decided to move away from the dense ice to avoid being trapped again. The submarine moved to a safer area of the water, where conditions allowed the expedition's scientific program to continue. For some time after diving under the ice, the crew members of the Nautilus continued their mission. They took samples of water and ice, studied the temperature and pressure, and took various measurements. Despite his fatigue, Wilkins enthusiastically tested the submarine's equipment, trying to record all the features of the vessel's operation in the extreme conditions of the Arctic. He carefully documented every malfunction, every successful or unsuccessful attempt, hoping that this data would be useful in the future for new, more advanced Arctic submersibles. However, new difficulties soon arose. The ice around the vessel began to rapidly contract, creating the risk that the submarine would simply be trapped in an icy trap. After a brief but decisive meeting, Captain Sloan Denenhauer and Sir George Hubert Wilkins made a fateful decision to return. Too much was at stake: the lives of the crew, the remaining technical capabilities of the vessel, and the very idea of future expeditions. In addition, Arctic storms were approaching, and any delay could end in disaster. On September 8, 1931, the Nautilus submarine arrived safely at Nordkapp, and on September 20th, it arrived at the port of Bergen. There, a lively correspondence began with the United States and the main investors in the expedition. However, Hearst, a media mogul and one of the main sponsors, refused to cover the costs, stating that the key objectives of the expedition had not been fully achieved. Although valuable research data had been collected, the planned sub-ice passage to the pole did not take place. This became the formal reason for refusing full funding. The crew, which had endured storms, breakdowns, Arctic cold, and the real threat of death, received only partial financial compensation. Soon, the team was officially disbanded. Meanwhile, an official order came from the U.S. Navy. After assessing the damage to the hull and the cost of towing, it became clear that returning the submarine home was not economically feasible. The decision was made to sink the Nautilus off the coast of Norway. On November 20, 1931, the submarine was towed to a depth of 347 meters and sunk. Thus ended the story of one of the most ambitious scientific expeditions of its time. Almost 3 decades later, on November 30, 1958, Sir George Hubert Wilkins passed away. Until the very end, he dreamed that humanity would conquer not only the peaks of mountains and the depths of the oceans, but also the most remote corners of the Arctic. His last wish was simple but symbolic: to scatter his ashes where he and his team had once accomplished the impossible, under the ice of the Arctic. And it was fulfilled. On March 27, 1959, the American submarine USS Skate, SSN 578, surfaced near the North Pole, the very place where the Nautilus had dived almost 30 years earlier. The crew honorably fulfilled the will of the great explorer. Wilkins' ashes were scattered over the icy sea, in memory of courage, science, and man's great desire to explore the unknown. By the way, if you are interested in unusual research submarines, our channel has a separate episode about the Soviet Bentos submarine project. These unique vessels were used in the Black Sea and performed many complex tasks, from scientific experiments to covert patrols.